In this problem, we need to determine which of these pictures describes the situation when this block is flipped over so that way the piece of iron is below the water. In order to decide which of these is the correct picture, we need to know the definition of the buoyant force, and we need to understand the volume of the displaced liquid. The forces acting on this object are gravity and the buoyant force, and because the object is not moving, then the sum of the forces is equal to 0. The equation therefore is the buoyant force minus gravity is equal to 0, and we see that the buoyant force is equal to gravity, and we can rewrite the buoyant force in terms of the density of the liquid, the volume of the displaced liquid, times gravity, and that will be equal to the gravity force acting on the object. The important thing here is the volume of the displaced liquid. The buoyant force isn't going to change when we flip the object upside down because the density stays the same, gravity stays the same, and the volume displaced must stay the same because this term isn't going to change. So, when we go to look at the pictures, we're going to be looking at one which has this amount of volume underneath the water. Looking at the options, we see that option B satisfies this requirement. Option A does not because the volume of the object that's underneath the surface of the water and which is therefore displacing the liquid is smaller than in the original case. In C, the volume of the liquid displaced is greater than in the original case, and in D, the object sinks, which doesn't make sense because the object floats initially and will float forever. So we're left with option B, and we see that the volume that is underneath the surface of the water is roughly the same as before, and that is because the volume of the displaced fluid must be the same because of this equation here.